Continuing our discussion of mobile security, let's look at the Android platform. The objectives here are to understand the basics of the architecture of the Android operating system, how the components fit together to build application, and begin to get an idea of the security model. We'll spend more time discussing Android than we will the other three of our mobile platforms because the Android system is open. And by open, we mean it's open source. The source code for the operating system is completely available. It's well documented. So we'll introduce some concepts using the Android operating system, and later, as we discuss the other operating systems, we'll compare and contrast with Android. Android is based on the Linux kernel. So if you are familiar with the Unix operating system design in general, this will be a familiar slide. The good news for you is that most of us will be living in the blue zone, operating with the Android application framework and the applications themselves. The libraries, the runtime, and the kernel are all written in C and C++. Our applications will be written in Java. We utilize the underlying Unix system and its basic security properties on the file level, and we take advantage of that both in the Android system, the iOS system, and on the BlackBerry. One particular customization is in the lower right-hand corner, the binder. This controls the inter-process communications between the various components of the Android applications, and this is a place of additional enforcement for access controls. In the Android world, we use some specific vocabulary. An activity is a single screen or an item that appears on the screen. This is the user interface for the most part. A service is a long-running task in the background. In the Unix world, we call this a daemon or a daemon. Services don't typically expose a user interface, so the activity will talk to and utilize the service. Content providers are a shared set of resources, application data, perhaps the SQLite database, web resources, the file system, or other persistent storage. And a broadcast receiver is that component of the application which listens for notifications from the system itself or other announcements. Think of an application that goes into the background when the phone rings. It's responding to a broadcast through the broadcast receiver. In context, examine a simple application, for example, a mail activity or a mail program. There'll be an activity to send mail, an activity to receive mail, and perhaps an activity to list mail messages. All of these will talk to services on the back end that send and receive the mail messages. And they'll deal with a content provider to store data locally on the system. The mail application will have a broadcast receiver so that it can receive broadcast messages from the system itself. For example, power is getting low, or incoming phone call, and respond appropriately. Messaging internal to the application uses a construct called an intent. This is an asynchronous message sent to indicate activities, a broadcast, or service. Sending an intent involves sending a message. A content resolver resolves requests from an activity. The manifest file, specifically the Android manifest.xml file, is written by the developer, and it contains resources and limits what the application can access. It identifies user permissions, what portion of the application can talk to other components. It controls access to the low-level hardware, such as the storage, the network, the camera, the GPS, and other resources, and communications with the APIs. Here's an example of the Android manifest.xml file. You can see it's written in XML, so even if you don't understand the exact syntax, you can get a sense for what is allowed. The reference at the bottom contains complete resources on what is allowed to go in the Android manifest.xml file. Permissions are declared in the Android manifest.xml file to protect and restrict the access of the program to data and system resources. The permissions define the application boundary, and they are defined in the android.manifest.xml file and controlled and enforced by the kernel, specifically by the binder within the kernel. Some examples of specific controls here using the system, reading, writing data, and setting system settings. Again, the permissions are defined at the URL provided at the bottom of the slide. Some more permissions: course and find location, access to the near field communication, external storage, SMS, and the full list is at the URL at the bottom of the slide. Now, as a security professional who has involved themselves at the beginning of the development lifecycle, it's important for you to work with your developers so that they understand what can and cannot, what must and must not be defined in this Android manifest.xml file. Understand the privilege of the principle of least privilege. Restrict the program and the user to the minimum permissions and accesses that it requires to accomplish its task. Consider need to know. If the user or the system or the application doesn't need access to location to perform its task, do not allow access to the GPS or to course location. If the user or application doesn't need access to the camera, do not allow it. Communicate this to the developer early in the development lifecycle and review it in the testing phase. Cause the developer to defend every access that he defines and allows on the principle of need to know and least privilege. Content providers work a bit differently than other permissions. These are used, content provider grants are used to control access to content providers, and URIs are a specific example. So here are some examples of a content provider grant providing access to the accounts table or a table called users. Grants implement a capabilities model for granting permissions, such as opening up a file attachment, and these are applied at the intent filter. So the intents are used for inter-process communication. There's a filter there that determines how the grants can be applied. The complete references for this are at the URL at the bottom of the slide. Now overlaying permission controls on our sample mail activity, you can see where these come in at the various layers, implementing another of our security principles, defense in depth. So, a checklist to review prior to deployment. Set the groundwork for this with the developers in the beginning stages of the development lifecycle. Prior to deployment in the testing phase, review that Android manifest.xml. Inspect the permissions for activities, services, intents, content providers, broadcasts. Examine in detail any customized permissions and content grants. Thank you.